All right. So we are in your notes, turning to the last section. So we have a little warm up here. Okay, I'm going to give you a couple minutes, or maybe I'll randomly call on y'all. I know y'all love that, right? Okay, so take a look for me. Okay, that light's a little intense. Okay, so take a second on your own paper, okay, or your whatever you're writing on. Okay, write those limits down for me. Okay, so for our first one here, this is a graph of F. This is a graph of G. This one's obviously plagiarized from mathbits.com. Okay, and so the first limit that you're doing here is the limit on the graph of G. Okay, so we're starting over here. I want the limit as x approaches -1 from the minus side, that means the left. From the plus side, that means from the right. And then on the third one, it's only a -1. That means it's a two-sided limit. Okay, so we should remember just from the last couple days that means that those have to match, the left and the right. So -1 is here. Okay, I can pull out my ruler if I need to. Okay, but I'm looking at that side. It looks like it's at a height of about 3. So I'm going to write that down for my left limit. Remember, for a left-sided limit, I cover the right side. And now when I want the right-sided limit, I'm going to cover the left side. So covering this side here now. I don't know if you can quite see that, but that's a height of 6, I think. Yes. Now, another distinction here that I want to point out is that my left side limit had a closed dot. My right side limit had an open dot. Okay, remember that for limits, nobody cares about that. Okay, doesn't matter. Okay, then the one other thing I'll add though is that what if I wanted, let's add this down here, f of or it's a g actually, g of -1. Okay, well for g, that's a y value, you care about open or closed. For a limit, you're just tracing as you get close to it. But for the actual y value, you would choose the closed dot, which we said is here at 3. Okay, so remember here, y values always have to be closed. Now, let's say that both of those were open, then you would say that point is undefined, okay? All right, so then last thing, my left limit was a 3, my right limit was a 6. That means my two-sided limit is a DNE. Good? All right, so next question. Let's do the limit as x approaches 4. Okay, that is a two-sided limit. Okay, and then I'm going to randomly call on you, so get ready to unmute yourself. Amelia, what is the limit as x approaches 4?
Would it be 11?
It would be 11. Very good. Okay, because as I look from the left and I look from the right, I can see, oops, that height is basically the same on both sides. Okay, very good. We got a tricky one here. Anybody want to volunteer on E? Question is, for what values of A does the limit as x approaches A equal 6? Okay, so any volunteers, just unmute yourself. What are we looking for there?
When the y value is 6, right?
Say that one more time.
Would that be 3?
When the y value is 6, like when it approaches the x?
Yeah.
You're looking for the x value when it equals 6 from both sides.
That's right. Okay, so from both sides, I need the y value to be 6. So just to make it easier here, I'm going to draw it. I know some of y'all can't hardly see this graph, especially if you're on a phone. Okay, but there's a height of 6, that pink line. So I want to know when the limit is going to equal that pink line. So ready? Here's what I want you to do. Everybody's going to do a yes or a no. Okay, what about this dot right here? Is that limit going to be 6? Yes. What about this one? Yes. What about this one? No. Why not? Because the right side limit is 6, but the left side limit was 3. So for my answer here, I would say A can be, that looks like 3, or it can be 5. Okay, but it cannot be -1. And remember, that's because this limit here is a two-sided limit as x approaches a. And we already said that the limit as x approaches -1, that doesn't exist. Okay? All right, next question here, please. Okay, let's go with Tyler, sir. Okay, we are doing the limit as x approaches -1 from the left side of f.
My computer shut off with my answers. I thought of it.
Okay. Here, I'll pick somebody else since you have to do that. Josh, tell me, what is the limit as x approaches -1 of the function of f?
Sure.
That's okay. Avery, help him out. -1 left side. What? It is 1. Okay, great. So remember, as I'm approaching -1 here, I'm covering up the right side. And then I'm looking, as I trace this graph here, what I'm getting closer and closer to. So I can see that here is at a height of 1. If it was a right side limit, I'd be on this chunk of the graph, okay? So my left side is going to be 1. That means that I want g of 1. And then I come over here to my graph of g of 1 is 2. Now, we talked about a rule yesterday that said that you can only use the composition property if the inside limit exists and the outside function is connected. So because this was a one-sided limit, that's why I'm allowed to use that rule, is because does the one-sided limit exist? Yes, it does. Then I can use my composition property that we learned yesterday. That's where you take your limit, jump it to the inside function, figure that out first, and then plug into the outside function. Okay, so let's look at the next one. I want the limit as x approaches -1 from the right of f of x. So let's go with Anna. Okay, what is my limit on the function f as I approach -1 from the right-hand side?
-2.
That is correct. So then I take my -2, that's my middle answer, and I'm going to plug it into g. And then remember, the second function you plug into has to be connected. So I look at g at -2, that's right here. Even though there is a break, it's over here at -1, that doesn't matter. So my -2, totally fine. My answer is going to be 3. So remember, the rules for plugging into the middle function are your middle limit has to exist and your outside function has to be connected, which it is at that value. Even though it has a break somewhere else, we don't care about that. Okay, next one, we're doing x approaching -1 from the left-hand side. Remember, that limit jumps to the center. So I'm going to find the limit as x approaches, oops, that's not an arrow, -1 from the left of g of x. And then I'm going to plug that into f. Okay, that's what we learned yesterday. That's your composition property. So the limit goes to the middle. I'm on my graph of g here. Okay, from the left-hand side, let's go with Jocelyn. As x approaches -1 from the left, what's my y value here? What's this middle limit here? So on my graph of g, as x approaches -1 from the left-hand side, so I'd be looking at this graph, but I only care about that side of the graph. So as I trace this graph over, what's my y value from the left-hand side towards -1? Say that louder one more time. So the right side is 6 over here, but we want the left side, so that would be 3. So remember that you want to pay attention to which side you're on. If it's a little minus down here, that means that you want this left side of the break. versus if it was a plus sign, you would be on this right side of the break for -1, okay? And then I come back to my graph of f of 3, I can see that's a quadratic function. F of 3 is going to be 5. Okay. All right, next one, we have the limit of g both times. So remember, my limit's going to jump to the middle first. So I'm going to do my limit as x approaches -1 from the right of g of x. Then I'm going to take that answer and I'm going to plug it into g, as long as the middle limit exists and the outside function is connected. Those are my rules. Okay, so looking at my graph of g here, okay, we're doing -1, but from the right-hand side. Okay, so that's the answer that we just said. It's up here. It was at a height of 6. Well, then that means that I want to know what g of 6 is. And notice that 6g happens to be that same graph because I used g both times. So g of 6 is right here. Looking for my y value, I see that it's a 0. Also notice my graph is connected. That has to be true for you to move on to that next step. Okay? All right, good job. Okay, so the last thing that we have to talk about using graphs are limits to infinity. Now, the good news is that you should have done this in pre-cal last year, at least a little bit. Okay, so if you're looking down here at the bottom, okay, and again, I know I see a few new faces. These notes are on Google Classroom. When you look at a limit to infinity, you are looking at the ends of the graph. So when you were in pre-cal, your teacher probably called this end behavior, okay? So if you want to write that at the top here, okay, end behavior. Okay, and so the way that your teacher probably wrote it is like this. They would say, as x goes to infinity, then f of x goes to, and they would write it like that. I don't know if that looks familiar. Can I get any nods? Do any of y'all remember that? Okay, good. I got a couple nods. So basically that's just a limit, but they didn't want to throw the notation at you quite yet. Okay, but you already know probably how to do that. So that's exactly what this limit statement here means. The limit as x goes to infinity describes the y value that the graph approaches as I go towards x to the right, versus negative infinity describes the y value that I'm approaching as x goes to the left, okay? So we're using these same two graphs up here. Okay, now remember, your choices are that either your graph is approaching a specific value, or it could be going up forever or down forever. So let's look at this one first. So we're using the graph of f, that's right here. Okay, I'm going to just sketch the graph right here for you. Okay, it doesn't have to look perfect. Okay, this is the graph of f. I'm just stealing it from above. Okay, that's the graph of f of x. So if I want to know what x is doing, or what f of x is doing as x goes to infinity, I'm looking at this end of the graph. Okay, it's either approaching a specific value, or it's going up forever, or it's going down forever. So out of those three choices, hopefully you can see my right end is going up forever. That means it's approaching infinity. Now, your other option would be to say that it doesn't exist, which is also true because it's not approaching a specific value. Okay, now let's do our left end. So notice here we have a negative infinity. That means that I care about this left end. Okay, and if your value is flat like that, you would still say the limit is that height. So for example, this was a 1 here, then I would say that limit is 1. And you could say, you could argue like, well, it's not really getting closer to 1 because it's just staying 1, okay, but that counts as a limit as well. So if your graph is flat, you would be like, okay, well, it's just staying at 1 then. It's not getting closer to 1, but it's not leaving 1 either, okay, if that makes sense. All right, let's do your graph of G now. I'm going to re-sketch it just so that I can draw all over it. Okay, you had a closed dot here, open dot here. Your graph went down, up, down. Okay, that's your graph of G of X. Same two graphs we were looking at up here at the top, just sketched in a more ugly way. Okay, so as I'm doing x going to infinity on g of x, I'm looking at the right end of the graph. Okay, I observe what the right end of the graph is doing. As x is going towards infinity, my y values here are going down. So I would say that they're approaching negative infinity. Okay, versus if I'm going to negative infinity for my x, that means I'm looking at the left end of the graph, which is here. Okay, and then if you look at your graph, that's a 3. 1, 2, 3. Okay, so I would say my x going to negative infinity, g of x is approaching 3. Now, like we just said, is it approaching 3? Well, no, it's staying at 3. Okay, but that also is a type of limit. Okay? Do we have any questions in general about that? No? Okay. So before we go on to these next 4, I'm going to turn the page here, and I want you, oh, those are all like that. Dang it. Okay, I guess we might as well do it. I was going to give you like one more little practice, but I don't have one really set up. Okay, so, all right, so composition of functions, you can do that as well for limits to infinity. You're still going to plug into the inside function first and then go to the outside. Okay, so let's say we're doing this one first. So the first thing I'm going to do is find the limit as x goes to infinity of g of x. Okay, that's the first thing I'm going to do. Then I'm going to plug that into f. Okay, so g of x, x is going to infinity. That's the right end of the graph. I know that that's a negative infinity, right? Because it's going down forever and ever and ever. Then what I can do is I can say, okay, well then I want f of negative infinity. And then I would go to the graph of f and I would look towards the left end. As my x goes back forever and ever and ever towards negative infinity, my y value is sitting right there at 1. Okay, and it's kind of weird, the notation, because that looks really ugly to me. That doesn't really make sense. But if you think about it's a limit, okay, then it kind of makes a little more sense, okay? So let's go right next to that and do the left end this time. So I'm doing x approaching negative 1. I'm going to apply that to my middle function here. And I said that wrong. I meant to say negative infinity. Okay, so I'm going to find my limit of g of x as x goes to negative infinity. Then I'm going to plug that result into f. Okay, then I'm going to look at the graph of g. As I trace x back to negative infinity, I'm staying right here at this height, which we said was a 3. Well, then that means that I'm going to go back to f, and I'm going to find f of 3. Now, I'm going to have to go back to my original graph on this since my graph kind of sucks. Okay, so let's come up and look at it. F of 3 here, we're looking at this guy. And I can see that at 3, it's at a height of 5. Okay? But remember, I just pulled the y value from there. Okay? That's this point right here was 3, 5. All right, 2 more left like that. Oh, we have something in the chat. Yes. Liam, did you look like you're still in here. Are you still in here? Hang on one sec, y'all. Yes, Liam, you should be able to rejoin. I don't even have my waiting room on. Did he make it back in? Are you in here, Liam? Scrolling. Liam, did you make it? He didn't. How do I message him back? Hang on one sec, y'all. I'm sorry. And then Loretta, yes, I will explain it again once I message this kid back real quick. Alec Fields is not able to get in the Zoom. Okay, thank you for telling me that. Let's figure out what is going on with this. Do this. Send it to Liam, maybe. Oh, it's because I spelled his name wrong. I'm such a dweeb. There we go. It's Alec with a C. Message Liam as well. Okay, it's just not in there, I guess that's the reason why. You guys are the most patient kids of all time. Okay, Amelia, tell Alec I just sent him the thing. Hopefully he can get in from that. Oh, Liam is back in. Okay, great. But Alec is still not here. Why is this? Okay. So hopefully he's able to get in. Use that link. Okay. So let's go back to your question that you had, and then hopefully those kids will be able to get in. So when you are doing a limit to infinity, your goal is to look at the end behavior of the graph. So if x is approaching infinity, you're looking at the y value on the right end of the graph. Okay? If you are doing x towards negative infinity, then you're going to be looking at the left end of the graph. So for example, on this graph, my limit to infinity as x goes to infinity was infinity because my right end was going up forever. So let's put left, let's put up, okay, forever. Okay, versus on my left end, it was flat at a y value of 1. Okay, same thing on my graph over here. My left end was flat at a y value of 3. So what I would say is, as x comes back to infinity, my y value is staying at a height of 3. Okay, versus as my x goes to infinity, I'm looking at my right end behavior of my graph. I can see my graph is going down forever. And so what that means is that I would put negative infinity because my graph is going down, down, down forever and ever and ever. Okay? All right, so now let's look at that next row. So I'm going to take my limit and apply it to the center. So I'm doing the limit as x approaches infinity of f of x, and then I'm going to plug that into g. Now remember, pretend the g's not here and pretend we didn't just do this problem 2 seconds ago. You're looking at the graph of f. I see x going to infinity. That tells me I'm looking at the end behavior on the right side. My right end is pointed up. That means that this is infinity. Then I want g of infinity. And then it's like, well, that's weird, but I know what to do. If I want my x value, remember, this in the middle, that's an x value. Okay, if I want my x value to be going to infinity, then I'm going to look at my graph of g over here. As x moves towards infinity, my graph is pointed down. That means my final answer is negative infinity. Okay, and then for my last one here, limit as x approaches negative infinity, that's going to jump into the middle with f. And then I'm going to take that result and plug it into G. So then I come over here to my graph. I'm looking at f. And if x is going to negative infinity, I'm looking at the left end to see what the y values are doing. So if I'm on the graph of f, on the left end, I can see they're staying flat at a height of 1. Then that means that I want G of 1. Okay, and then I would come over here to my graph at 1. Really, I'm going to have to look at the original graph because mine is just a sketch, right? So at 1, I can see my height was 2. Okay, and then I can come up and show you if you are looking only at my screen. Okay, but look right here. Okay, G of 1, my height was 2. So if you want to label that on here as well, you totally can. 1, 2. Okay, that's how I knew that. Okay? All right, so let's do a new problem set. Okay? And I don't mind waiting. Do we need to wait or is everybody kind of good? I know we had a weird break already. Good. Okay, give me like a stop hand in the name of love if you need to wait. Okay, all right, looks like we're good. Okay, next question. All right, so before you do these compositions, I want you to just do the regular limits, okay? So to the side, I'm gonna write 2 limits here. This side is the limit as x approaches infinity of f of x. And then on this side, I want you to do the limit as x approaches negative infinity of f of x. Now, important distinction here. This is something my pre-cal kids always get confused on. They're like, oh, well, this side's going down, so that's why this is a negative infinity. No, that's on the x-axis. X going to negative infinity means that you're moving to the left. So that means that you're going to be looking at the y, oh, that pen is dead. You're looking at the y values on the left end. Okay, and you're looking to see what they're going towards. Versus x approaching positive infinity, I want the y value on the right end. Okay, so I'm going to give you a second to take a stab at both of those. And then if you want to, go ahead and do it for your graph of G right next to that. So you're doing your limit as x approaches negative infinity on f. Then your limit as x approaches positive infinity. And then you'll do the same for G. Okay, so as x goes to negative infinity, that's this graph right here. As I trace this down, my end behavior tells me that that's going to keep going down forever and ever and ever. So you should have put negative infinity. Okay, for my right end, I'm looking at x. There should be a asymptote there towards 0. Okay? So you can kind of see that it kind of curves off. Okay, so I'll give you a second. I want you to write the full notation for the graph of G. So we're going to have 2. We're going to have the limit as x approaches negative infinity of G of x. And then the limit as x approaches positive infinity of G of x. Okay, and then sorry to annoy y'all, but I'm going to send out the correct Zoom link just through Remind real quick. Okay. All right, so for that first one, limit going to negative infinity. Somebody, let's see who we can pick. Emily. Okay, as x goes to negative infinity, what's my y value doing on my graph of G?
It will be 2.
It's actually going to be, that should be a 1. But yes, I see. That's like this is your first dot, and then this is your 2 right here. Okay, and then what about towards positive infinity? Jennifer, tell me, what would that be? As x goes to positive infinity, what's my limit?
infinity. Positive infinity. Can you hear me?
Positive infinity is correct. Good job, Jennifer. Okay, so now we're going to do all of our next one. Okay, so remember, you take your limit, apply it to the middle. So I'm going to find the limit as x approaches infinity of g of x, and then I'm going to plug that result into f. And then remember, even though it's math, as g went to infinity, my answer came out to be infinity. I can just steal that from right here. Well, then I really want to know f of infinity. And then I can look at as x goes to infinity, what was f doing? It was going towards 0. So you start with the inside, find that first, then go to the outside. Let's look at b. X is going to negative infinity on my inside function, which is f of x. Then I'm going to apply that to g of x. So then I would say, okay, well, look at f going to negative infinity. That's this side. My graph was going down forever. You can trace the y value. So that means my middle is a negative infinity. Then I want g's behavior as x goes to negative infinity. And if I look at the graph of g towards negative infinity, I can see it staying flat there at a height of 1. Okay, last two with those graphs. Okay, f in the middle. We want x going to infinity first. Then we're going to plug that into g. So I'm looking at f going to infinity here. As my x's go forward and forward and forward, my y values get closer and closer to 0. So that means my middle there is a 0, then I want g of 0. And then when I look at this graph, it must be connected for me to choose that y value. And so when I look at g of 0, I can see I'm at the origin here, so that's going to also be 0. But remember, I can only choose that if my graph is connected. Okay, last one like that. X approaching negative infinity, we're moving that into our g graph. And then we're going to plug that result into f. So g going to negative infinity, I'm looking at this guy right here. As x goes to negative infinity, my g's are staying at a height of 1. Then I can take my 1 and plug that into f if it is connected. And then when I look at the graph of f, what you should notice here, okay, is that at 1, I have a break in the graph. That means that this limit does not exist. Okay, and then remember that after you put DNE, you should go back and either cross out your equals sign, or you should scribble it out because your writing is going to be graded on the AP test. Okay? All right, so let me give you a sec here to try these first two right here. Okay, and then what you should see, I'll go ahead and highlight them for you, is that you have a horizontal asymptote this way and a horizontal asymptote here as well. Okay, and then you have a vertical asymptote on this graph here. And then let me be specific on what I'm asking you to do. I want you to do the one-sided limits just like we did last time before you do your big ones. So I want the limit as x goes to infinity. I want the limit as x goes to negative infinity for f. Then I want the limit as x goes to negative infinity for g of x. And then I want the same thing for the right side. Okay, let me zoom out so you can see those 4 things. Okay, and then once you do those 4, you can do A and B. I don't know if you guys saw, but all the face-to-face classes go back in September. They came out with like an announcement about it. So, I mean, it won't affect you guys, but. Okay, so let's do this one first. X is going to negative infinity. F of x, the y values are doing what? Let's go with Taylor. Okay, what's happening on this left end of this graph for that first one? Taylor Thomas. Oh, you gotta unmute yourself. Silly girl.
Going to negative infinity.
Okay, now remember, negative infinity means that your graph is going down at this end forever and ever and ever. Is it going down? What's it getting closer to? You got it. It's 0. Okay, so my x is going to infinity because I'm going to the left forever, but the end behavior is what my y values are doing. So if they're getting closer and closer to the x-axis, that counts as a height of 0. Okay, let's do another one. Let's go with Lucas, sir. What will my limit to infinity be for f of x? Okay, Lucas Capone. What would that one be?
0.
Correct. Very good. Okay, let's go with another torture victim. Let's go with Liam. Okay, as x goes to negative infinity on g of x, I'm looking at my left end behavior. What are my y values doing on this side?
Approaching negative infinity.
You got it. Okay, that's negative infinity. And then Alec, now that you're back in, let's see what you know. As x goes to infinity for g of x, that's the right end of the graph. What are your y values doing?
You're getting closer to 4.
1, 2, I think that's 3. But yeah, I know it's hard to see. Okay. All right, so we're coming down here. I want the limit as x approaches infinity. But I want to plug it into my middle function first, which is an f of x, and I'm going to plug that result into g. Okay, that's my composition limit property. Okay, so limit as x goes to infinity on f, that's this side. As x goes to infinity, my y value is approaching 0. So that means that I'm going to go to the graph of g. I'm going to find g of 0. If the graph is broken, the answer is DNE, but it's not. G at 0 looks like it's about 2.5, we'll say. Okay, it's not perfectly on there. We'll put ish. Okay, 2.5-ish. Okay, next one. We want x going to negative infinity. We're going to apply that to the middle. G of x here. Plug that into f. Okay, I'm looking at the graph of g. Okay, the negative infinity tells me I need to be looking at the left end of the graph of g. So the left end of the graph of g was here, and it was going down forever, which told me it was a negative infinity. Then I need to know f of negative infinity. And then I look at my graph of f towards negative infinity. Okay, just like I think it was Taylor said, okay, my graph is going towards 0. What you think about that? Good? Bad? Easy? Hard? What do you say? Okay, so the other thing, and I think this is the real last thing that you have to learn, I feel like I say that all the time, about limits is going to be one-sided limits, but basically the same exact rules apply. So let's say that I'm doing this guy right here. I want the limit as x approaches -2 from the right side, and then remember, I'm going to apply that to the middle. So I want the limit as x approaches -2 from the right side on the graph of f of x. Okay, then all the way around that, I'm going to eventually plug that into g, but let's just look at this middle part right now. Okay, yesterday, or maybe, I don't know when it was, sometime we talked about that if you're at a limit, if you're at an asymptote, a vertical asymptote, and you're approaching that x value, okay, you can put DNE, but you can also put the direction of the asymptote. So for example, if I'm looking at f at -2, that's right here, but I'm on the right side of the graph, that's what my plus means. That means this whole left side is gone. And I'm observing what's happening as I approach this x equals -2 from the right side. My graph is going up and up and up and up and up forever and ever. Then I would say this one-sided limit is infinity. And then I would find g of infinity. So horizontal and vertical asymptotes both have that same rule, okay? And then I would go to my graph of g. Infinity tells me that my x's need to be at the right end of the graph. and I can see that it's approaching a height of 3 because I had an asymptote there. Okay, now let's do the left side. So now I'm finding the limit as x approaches -2 from the left of f of x. Then I'll eventually plug that result into G. Okay, I'm looking at my graph of f. This little negative tells me I want the left half of the asymptote. So I'm going to cover up the right side, and then I'm going to observe what's happening right here. Okay, as my graph approaches that asymptote from the left side, I can see it's going down forever. That tells me it's a negative infinity in the middle. And if that's a negative infinity in the middle, then I can go to my graph of G. I can look at what's happening at the left end, okay? So remember that this is your X value. So that tells me I'm looking at the left end behavior. Okay, and remember, end behavior is always referring to what your Y values are doing. Are they going up? Are they going down? Are they flattening out? Whatever, okay? So then G of negative infinity, I can see that graph is going down forever, so that would be negative infinity. How do you feel about that? Good? Bad? Not so good? Okay, so we have one more page that I just want you to practice. I think it'll be pretty hard for me to show you the whole screen clearly on here. So if you will go to Google Classroom, then you can see that last page a lot more clearly. But I'm going to give you, we have 14 minutes. So I'm going to give you maybe 8 of those minutes. I'm going to put you in breakout rooms. If you are super confused, leave your breakout room, come back, and we'll do it together, okay? And then worst case scenario, if you are totally lost after you go to the group, you think you got it, and then you get them all wrong, okay, then you can just watch the end of this video and watch me explain it to the people in my room, okay? So we are going to breakout rooms. Oh, hold on, we got some chats here. Isn't that a vertical asymptote on G of X? Okay, so thank you for asking that, Tyler. I pulled all these graphs off Google. So the reason I would say that I know there's a vertical asymptote here is, do you see how they put that little dotted line in there? That's how I know this one has a vertical asymptote, versus on this graph, I don't actually see that they drew in a dotted line. So you're right to wonder, is there an asymptote there? Maybe. But from my perspective, from what I see on the graph, I'm not that confident that it's an asymptote because I don't see that dotted line. Okay? And the other thing I'll tell you, just for, I love how they're letting students, yeah, you're right. I don't know about all this. And then do you have one other? F of X caps off at 0 because the asymptote f of X. Okay. Hopefully that answered your question. If not, then just come back. I love to help, okay? So you are working on this last question, okay? And then you'll notice, okay, that just like this is what they do on the AP test, they would tell you in the question where the asymptotes are. So for example, here it says f of X has horizontal asymptotes at y equals 1, or it has a horizontal asymptote at 1, so that's right here. Okay, so I know I have an asymptote there. And then it says G of X has an asymptote at -2. Now notice, I don't know if you remember this from pre-cal, but you can have an asymptote only go in one direction. Okay, so for example, this one to the left, I have an asymptote, but it does not tell me I have an asymptote here. So that means that side has no asymptote. Okay, and when I say HA, what I mean by that is horizontal asymptote. Okay, then it says finally right here, both graphs have vertical asymptotes at 0. So that means that this is a vertical asymptote and this is a vertical asymptote. Okay, and then like I said, I pull a lot of these graphs off Google, so I kind of look for the dotted line, but on the AP test, it would specifically tell you whether or not you had an asymptote. Okay? All right, so I'm going to put you in breakout groups, and then here's what we're going to do. I'm going to let you have the rest of class to go over these since we only have like 11 minutes, and then we will go over the answers next class. But I'll send them to you so that you can check your work, okay? So you are going into breakout rooms. Before you do that, if you have not put your name in the chat, I need you to do that now, please. Remember, I take attendance from the chat, especially since this is a bigger class, okay? And then if you have no idea what you're doing, Bebe, come back to my main room. I love to help, okay? Here we go. And y'all talk to each other and help each other, okay? Hey, okay. So, Kayla, how can I help you, ma'am?
So first you would start by doing like just the actual the graph limitation, like the limitation of x equals x as it goes to negative infinity.
Yeah, so let's do that one first. So as x goes to negative infinity, what is f of x approaching? Correct. 1. Okay,
I use the y, right?
you use the y, correct. And you want to think about the reason how come you would do that is what does f of x stand for? The y value, right? So it's saying as x goes to negative infinity, f of x, which is just another way of saying y, is going to 1. Okay, what about on the other side? As I go to infinity, what are my y values going towards?
0.
Now this one, you're asymptotes on both sides. So it's only approaching, this is still 0's way down here still. So it's flattening off at 1. So that would be 1 on both sides. All right, what about my g of x graph? So as x goes to negative infinity, okay, that's the left end of the graph of g of x, where are my y values flattening off to? What y value?
-2.
Correct. Okay, and then what about on the other side as x goes to infinity for g of x? So if it just keeps going up forever and ever and ever, what could I put that limit equals?
Infinity.
You got it. Okay, so first one. We're doing the limit as x approaches infinity of g of x first, and then we're going to plug that in to f. So what's my limit for g as x went to infinity? And then I want f of infinity, which means I want the end behavior on the right side of the graph of f. What is that curving off to? You got it. Okay, try the next one.
F of -2.
Correct, yeah. So your middle limit as x approaches negative infinity of g of x is -2. And then you're going to find f of that. And what's f of -2? Looks like it's about a half maybe. Okay, you can put ish behind it if you want. It's probably not exactly a half, but it's close enough. Okay, next one. Okay, x is going to infinity on f first. And then I'm going to plug that into g. Okay, g of 1, which would be what? job. Oh, hey, Jordan.
Hi, Miss Joyner.
How's it going?
It's good. I have a question on like E through H.
Okay, perfect.
Those are the vertical asymptotes.
Uh-huh.
Like 0.
Okay,
Like, so it'll never
let's do them
0.
on E. So you have this, right? 0 from the right of f of x, and then we're plugging that into g. Yeah, you have that written so far?
Yeah.
Okay, so then what would you say for that middle limit?
I don't know.
Okay, so my plus is my right side. So I'm going to come to the graph of f. I'm going to eliminate the left side of the graph, so that's all gone. And then I'm going to look as I trace closer to 0 on like x equals 0 towards that asymptote. Where is the end of the graph going? Is it going up or down?
Up.
Up, then that means that that goes to infinity.
Oh, okay.
Okay, does that make sense? Because remember, f of x is telling me what my y values are doing. So as we get closer and closer to 0 from the right side of the asymptote, f of x is going to infinity, then I want g of infinity.
Okay.
And then I would go to my graph of g. As I approach infinity on this right side, remember we didn't have an asymptote, so you would say that goes to infinity. Because it's going forever, it's not curving off to a specific number.
Okay.
Okay, so now try f.
Okay.
Okay, so what is my left side limit as x approaches 0 for f?
It's negative infinity, right?
Yes, correct. So then I want g of negative infinity. And what is g doing as x goes to negative infinity? -2, right?
Yeah.
Yep. Okay, 2 more left. So you want the limit x approaches 0 from the right of g, and then you're going to put that into f. And then remember, the plus just is telling you what side of the asymptote to look at, and you're looking for where the y values are going. So on the graph of g, which direction on the right side are my y values headed?
Up.
Okay, let's come up and look at our graph. So here's 0. So it's my pink asymptote. I'm covering up the left side. Remember, you have to be getting closer to the asymptote.
Oh, okay. So it's going down.
Yes. So that would be a negative infinity.
Okay.
And then on f, my negative infinity limit was a 1. Okay, so try that last one. Okay, and then Jakayla, how you doing, hun?
I'm good. Is D 0?
D, let's see, we'd have the limit as x goes to negative infinity of f of x. That would be 1, and then you'd want g of 1, which is 0. Yes, ma'am, it is. Good job. Okay, and then Jordan, what'd you get for that last one?
Would it be the same thing as the first one?
Yes, because your limit, whether you're coming left or right side, it doesn't matter. You're going down either way.
Okay.
Makes sense.
And then how did you half on B?
Okay, so on B, we did the limit as x goes to negative infinity on g. So that was giving me -2, yeah? Okay, and so then from there, I had to find f of -2, which if you look at your graph at -2, it's kind of like halfway in between 0 and 1. So remember, this means the y value of the graph at -2. That's what f of -2 means. And then I'd come over to my graph and I'd look right here to see how high it is.
Okay.
What did you put originally?
We're not going to talk about what I put originally because I don't know why I put it that. I don't know why I did that. I thought that I got my values wrong from my graph.
Oh no. Okay.
So we're just, nope.
Okay, well, a good thing that you could try is your homework, that very last section under limits is on this. So that'll maybe
Okay.
give you some confidence as you go through it, and it'll give you explanations if you get it wrong.
Yay.
Okay. All right, good job, good job. Well, then I will see you tomorrow morning.
Okay.
Okay, bye, ladies. Have a wonderful.
You too.
Thanks, bye.